Welcome to WISE Software's VisualCAM DRC DFM video series. In this video, we will provide a brief overview of the available DRC DFM analysis checks included in VisualCAM. The first set of analysis checks provides information about your design that can be particularly useful in cost estimation and process evaluation. Minimum air gap reports the shortest distance between any two items in the design. Conductive layer count reports the total number of conductive layers. Board size reports the extent of the border layer if one exists. Otherwise, the extent of the conductive layers is reported. Drawing and other graphical layers are ignored. Hole count reports the NC layer, tools used, and the number of drill holes per tool. Hole size count reports the number of tools used on each NC layer. The buried vias and blind vias checks report the upper and bottommost start and end layers for buried and blind vias. Blind and buried layer sets must be defined in the design in order to run this analysis. Stacked blind buried vias reports whether blind buried vias in different layer sets are stacked on top of each other. Blind and buried layer sets must be defined in order to run this analysis. Minimum pad to drill reports the minimum annular ring spacing from copper pads to plated through-hole drill hits. Minimum drill to drill reports the minimum spacing between drill hits. Minimum non-plated through-hole to copper reports the minimum spacing between non-plated through-hole drill hits and copper on external and internal layers. Minimum pad to pad reports the minimum spacing from one pad to another for each conductive layer. Minimum pad to trace reports the minimum spacing from a pad to a trace for each conductive layer. Minimum trace to trace reports the minimum spacing from one trace to another for each conductive layer. Minimum pad to mask reports the minimum annular ring spacing from mask openings to their corresponding copper pad on the top and bottom layers. Minimum thermal to drill reports the minimum annular ring from thermal reliefs to plated through-hole drills. Minimum plated through-hole pad size reports the size of the smallest pad that has been pierced by a plated through-hole drill for each conductive layer. Minimum trace width reports the smallest trace width used on each layer in the design. Minimum Smd pitch reports the minimum center-to-center spacing of Smd pads. A pad must be identified as SMT in the aperture list in order to be checked. Legend on plated through-hole count and legend on non-plated through-hole count report the number of occurrences of the silkscreened legend touching pads on the top and bottom layers. Missing hole count reports the number of instances where a through-hole pad on a conductive layer appears to be missing a drill hit. Mill path length reports the total linear distance each tool travels per NC layer. Maximum plated through-hole registration shows the greatest amount of misalignment of data on drill and conductive layers. It reports the maximum spacing of plated through-hole drills on an NC layer from their corresponding pads on a conductive layer. Exposed copper count reports the number of occurrences of traces exposed by adjacent mask openings. Copper sliver count reports the number of occurrences of copper slivers. Any areas of copper that are less than the size you specify will be considered possible copper slivers. Mask sliver count reports the number of occurrences of mask slivers. Any resist areas that are less than the size you specify will be considered possible mask slivers. Next, we will review the design rule checks available. Pad to pad is the minimum spacing allowed between pads. Pad to trace is the minimum spacing allowed between pads and traces. Trace to trace is the minimum spacing allowed between traces. Border is the minimum spacing allowed between any item in the border. Minimum pad is the minimum pad size allowed. Minimum trace is the minimum trace size allowed. Stubs is any trace that touches a pad or trace on one end, but does not on the opposite end. Drill to drill is the minimum spacing required between adjacent drill locations. Drill annulus is the minimum annular ring required between conductive layer data and drill hits. If you select the isolated yes property, then any isolated drills not touching copper will be reported as an error with an annular ring size of 0. Direct to plane checks for drill locations on plane layers that represent a direct connection. You may select to include plated, non-plated, and/or vias. Note that there is potential overlap with the direct-to-plane options. For example, since most vias are plated, disabling the check for plated direct connects will have the side effect of disabling most or all reporting of direct connect vias. Drill to copper is the minimum space required between copper entities and drills. Separate tolerances are available for plated through holes and non-plated through holes. Pad to top mask and pad to bottom mask are the minimum annular ring required between the pads and the solder mask. Drill to top mask and drill to bottom mask are the minimum annular ring required between the drill and the solder mask. Missing top mask and missing bottom mask check for pads without openings on the solder mask. Pad to top silk and pad to bottom silk are the minimum clearance required between pads and the silkscreen layer. If you select a mask yes property, then the silkscreen layer is instead compared to the corresponding solder mask layer. Via to via is minimum spacing allowed between vias. Via to pin is the minimum spacing allowed between vias and component pins. Via to trace is the minimum spacing allowed between pads and traces. Via to border is the minimum spacing allowed between vias and the border. Via to drill annulus is the minimum annular ring required between vias and drills. Via drill direct to plane checks for via drill locations on plane layers that represent a direct connection. Via drill adjacency is the minimum spacing required between adjacent via drill locations. Via top mask and via bottom mask are the minimum annular ring required between vias and the solder mask. Via drill top mask and via drill bottom mask are the minimum annular ring required between via drills and the solder mask. Via top silk and via bottom silk are the minimum clearance required between vias and the silkscreen. If you select a mask yes property, then the silkscreen layer is instead compared to the corresponding solder mask layer. Via missing top mask and via missing bottom mask check for vias without openings on the solder mask. Via minimum size is the minimum via size allowed. Missing drill checks for pads that do not have a corresponding drill hit. Any isolated drills not touching copper will be reported as an error with an annular ring of 0 size. Coincident drill checks for drill hits that are in the same location but are different sizes. Redundant drill checks for drill hits of the same size that are in the same location. And mill path checks compensated mill paths for errors introduced by the compensation, such as arcs that implode, paths that cross over themselves, and any brake tabs that become invalid because the compensated path is now too short for the tab to fit. In the Design for Fabrication folder, acid traps are areas where etching solution accumulates but does not flow out during manufacturing. This causes over-etching, which hurts yield. This analysis detects potential acid traps in your design. Any areas where acid is likely to accumulate that are smaller than the size you specify, and any items, such as traces, pads, etc., that form an angle smaller than the one you specify, will be considered possible acid traps. Because the acid trap analysis looks for areas that are not fully enclosed, it is recommended that you run the resist sliver analysis in conjunction with the acid trap analysis for a thorough check of your design. Copper slivers are areas of copper that are so narrow that they will likely flake off. This command detects those potential slivers on the selected conductive layers in your design. Any areas of copper that are less than the size you specify will be considered possible copper slivers. Resist slivers are similar to acid traps and are small areas of resistive material that have a surface area too small to adhere to the board and can therefore flake or peel off. Where acid traps are open at one end, resist slivers can be fully surrounded by copper. Depending on your process, the resist slivers test will often find items that are also considered acid traps or pinholes. Resist areas less than the value you specify are considered resist slivers. Top mask slivers and bottom mask slivers are solder mask slivers, area where the resist is so narrow that they will likely flake off, float, and redeposit themselves in an area that might be soldered later. Any resist areas that are less than the size you specify will be considered possible mask slivers. Isolated thermals are over-etching of surrounding items that can result in a thermal being isolated from the rest of a negative plane. This analysis function allows you to hypothetically oversize the data on the negative plane layers by a specified amount, and determine its effects on the connection of the thermal to the negative plane. You specify the amount of over-etch that you wish to apply to the data on the specified plane layer. Note that a thermal can be considered isolated by virtue of its design. For example, if a thermal has ties that are 2 mm wide and the over-etch is specified as 1 mm or larger, the thermal is isolated. Starved thermals analysis verifies whether each thermal connection to the negative plane is valid, or has been constricted by adjacent data that is too close or overlapping. You specify the percentage of the thermal's tie width that can be unblocked by objects. This makes the clearance check relative to each thermal's tie width. The thermal is considered starved if the connection from the interior of the thermal to the exterior, measured across the minimum distance between the cutouts of the thermal and any other nearby data, is less than the specified value. The clear value is how many thermal ties must be clear in order for a thermal to be considered not starved. If you specify 0, all ties must be clear. If you select 1, one tie must be clear. Be aware of the number of ties in all the thermals in your design. If you select 4 as your clear value and have thermals with 2 ties, then those thermals would automatically be flagged as starved even if both of their ties are clear. If you have several different types of thermals, it is recommended that you leave the clear value at 0. Top solder bridges and bottom solder bridges are openings for pads on a mask layer that may be oversized too much and expose an adjacent trace or another conductive object. The copper for that pad may accidentally get too close during fabrication and create an unwanted connection or bridge to the adjacent object. The bridge distance is the distance between the pad and objects in the same mask openings, where the solder can possibly create a bridge. If the adjacent object is closer to the pad than this distance, it will be identified as a possible bridge. The position tolerance tests for shifting of the placement of mask openings. This check hypothetically oversizes mask openings by the amount you specify, to check if other conductive objects are then exposed by the mask opening. If an object is exposed and is also within the specified bridge distance to the pad, then an error is logged. Pinholes are voids in an area of solid copper that can cause acid to pool and over-etch the surrounding copper, or can cause resist flakes, potentially causing conductivity problems. Pinholes often result from inaccurate vector-drawn data that leaves tiny voids between the overlapping draws. You specify the maximum size of the pinholes to be detected. Areas which are less than this value will be considered pinholes. Smd Pitch checks the center-to-center spacing of adjacent Smd pads to determine if they are too close. A pad must be identified as SMT in the aperture list in order to be checked. Smd Spacing checks the edge-to-edge spacing of adjacent Smd pads to determine if they are too close. A pad must be identified as SMT in the aperture list in order to be checked. Layer registration checks your drill layer against the top mask and any other conductive layers you select. If 2 items are within the tolerance distance you specify, they are considered to be at the same location. In the Design for Test folder, test point to test point is the minimum spacing allowed between test points. Test point to exposed copper is the minimum space required between copper entities and test points. Test point to mill path is the minimum space required between test points and mill path entities. Test point to border is the minimum spacing allowed between a test point and the border. Test point to component is the minimum spacing required between component outlines and test points. Test point to mask is the minimum annular ring required between test points and the solder mask. And test point missing checks for nets with no test points. In the netlist compare folder, net shorts are the multiple external nets that touch one internal net. Net opens are multiple internal nets that touch one external net. No copper means no pad exists at the external net location. No external means no external net point exists at an internal net point. Pad probe validation is the probe point pad size in the external net differs from the internal net pad size. Note that the NLC analysis are the same as those performed by the analysis netlist compare command. This completes the DRC DFM overview of the available analysis checks. See our 2 other videos in the DRC DFM video series to learn how to set up and run the analysis checks and how to find and fix errors.